I'd like to talk a little bit about a couple of important concepts in trigonometry, one being pi and the unit circle and radians. There will be no proofs in this discussion. I'm just wanting to lend some intuition on these topics just so they don't seem so foreign to us. Ratios will be the stars of this discussion. Ratios in the form of fractions. And a ratio is just a comparison of two numbers. And we like to work with ratios because they just make equations easy to manipulate, and they work well with other ratios. And in this discussion, we will see just how valuable ratios are in mathematics. Now, if you recall back in the Stone Age, I believe it was Archimedes in, like 200 BC, he came up with a ratio that compared the circumference of a circle to its diameter. And he put that comparison in the form of a fraction. And the circumference was in the numerator and the diameter was in the denominator. And he called that ratio pi. And that ratio pi is always the same number. It's approximately 3.14. It goes on forever and it never repeats. We call that an irrational number. Always remember, though, that this number, 3.14, which is pi, that it is a ratio, and that meaning that it is comparing two numbers. Even though it looks like one number here, it's actually comparing two numbers, the circumference to the diameter. Now, if you think about it, there's a lot of fractions that compare two numbers. In fact, that's what fractions do. They compare two numbers. For instance, if you had a pizza, and say this is the pizza, and it was in 8 pieces, say, and say you ate 2 out of those 8 pieces. So basically, you ate 2 out of the 8 pieces. And you are just comparing two numbers. The 2 pieces that you ate compared to the 8 pieces that were originally there. So that's all we're doing with all of our other ratios. We're just comparing two numbers. Now, the fact that pi is irrational is very interesting. I mean, if you think about it, I mean, we're talking about a circle here. We're not talking about, a polygon that has distinct endpoints. We're talking about a circle that is basically, a circle is an animal all itself. It's pretty much set apart from the rest of the geometric figures. And every circle is similar to every other circle. And if you think about that, with similarity, if two figures are similar, say this rectangle and let's say this rectangle, and the reason that they're similar is because um, we'll just use our fraction 2/8 again. One side is 2, the other side is 8 on this rectangle, and on this rectangle one side is say 4 or 1 and the other one is 4. Well, this side compared to this side, the big one, is 2/8, and this side to this side on the small one is 1 compared to 4, and you can see that they equal each other because 2/8 will reduce down to 1/4. So really both of these, well, we won't do it that way. Both of these figures reduce to 1/4. And so we say they're similar. They reduce to actually the same number. Well, that's what happens with circles. Every circle reduces, or every circle's ratio of the circumference to the diameter reduces to 3.14. And, well, let's see. Let's get the eraser out here. Okay. All right. We're going to actually, we're going to use pi in a few minutes, but we're going to leave the discussion on pi and go on to the unit circle discussion.